Okay, so in this video, I'm going to review the rectilinear propagation stations that you completed yesterday. So what I'm going to do for each station is go through and show you the ray diagram of what you should have seen and the explanation as to why you have seen that. I'm also going to try and connect to the understanding of the idea that light travels in straight lines and explain what would happen or what you would have seen if light didn't travel in straight lines. So if you look at station A, that was the shadow puppets one, where you had a light source, your hand, and then the screen. If you look at my ray diagram, I took made a ray from the top of the light source and angled it down to hit the hand and extended it as well. Only part of that light source, or only part of that light ray may be hitting the screen, and that's where you get that penumbra, or the lighter gray shadow. I did that same with the bottom of the light ray, and I connected it to the top, and again, only part of that light may be hitting the screen, and there's the penumbra. And then I took one ray and I put right across to the hand, and obviously all of that light's blocked, so that creates all of that light in the middle. That's creating the umbra, or the actual shadow on the screen. So if light didn't travel in straight lines and was able to bend around objects that were opaque, this is what it would look like, or something like this. A ray diagram, it can still go straight, but then it hits the object, the hand, and it, as you notice, all of the rays are kind of bending around it and still hitting the screen. So that would result in not having a shadow. So this station, the station A, or the shadow puppets, gives us a little bit of evidence to show that light travels in straight lines, because if it didn't, we wouldn't have shadows. If light was able to bounce around and go around objects, there would be no darkness. So if there was the light source, there would still be light being able to hit whatever. So for instance, if you're outside in the summertime, or any sunny day, I guess, and the sun, so here you are, and the sun hits you, usually you would see a shadow, right? So here's my sun up in the sky, but in this case you wouldn't, because the light would decide to go around you, and you wouldn't have a shadow. So either you are a vampire, or something funky's going on with that light source. The second station was the station B pinhole camera. So you'll see my poorly drawn pinhole camera and my candle, and what I did is I drew a ray diagram, again starting on the top, taking a ray from the top and extending it through that pinhole and onto the screen. If you were able to see it clear enough, you would have noticed that the image of the candle, or the light, was upside down. So this gray diagram shows why it's upside down. The light travels in straight lines, and it has to go through that hole in order to capture that image, or capture the light on the screen. So that's the ray diagram for that one. If light didn't travel in straight lines on this one, I'm going to try and draw it. There's my screen, there's my pinhole, and there's my candle again. This time the candle's just going to be black for time's sake. I'll color it in maybe. There we go. There's my candle. If light didn't travel in straight lines, and it could bend and it could do whatever, the image wouldn't be consistent. So here's my light. I can go in straight lines, I can hit here, and I could bend down there. So my top could still be down there. If I took a ray diagram, a ray here, and it could bend and hit this, it might be really, really large, it might be upside down. It's still upside down, but it might be really, really large, and the image wasn't actually that large, right? Remember, it extends completely. It may not even react like that if light could bend. It may actually just, there's my ray, sorry, in the first one I forgot to put my arrows. So it could actually show that the light was right side up, if the light was able to bend. But in this case, we know rectilinear propagation says that light has to travel in straight lines and it cannot bend. Okay, in station C, this was the light at the end of the straw. So when you were using straws to shine a light through and hit the screen or hit the whiteboard. So what's happening there is simply when you take the straight straw, and I'm going to draw a ray diagram again, you hit this straight straw, the light goes straight through it and it hits the screen, and it ends up with showing a bright light, bright dot on the screen. Now, in the bent case one, the light is still going straight and it's hitting the bent part of the straw. Some of it's reflecting off, and I'm going to show it by dotted line, and you may have seen just a faint part. That's not because the light's actually bending there, because there's nothing to cause it to bend other than the straw itself, and it's a little bit reflective. So this is a reflection of the light rather than the light's being bent. So how does this show that light travels in a straight line? Well, if it didn't travel in a straight line and it was able to completely bend or bounce, we would see something like, draw another straw, we would see something like this. So here's my straw, bendy straw, and the screen again, and our light source. Okay, we would see, it wouldn't have to follow that, it wouldn't have to follow the law. So once it hit that bend, it could go boom, 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 and then come out. And what you would see is, again, you would see the full brightness of that light, because all of the light rays would be able to bounce around and hit that. Now, light has to travel in straight lines. When it hits opaque objects, it either is absorbed, it's reflected off, or it's absorbed or reflected off. So again, when you saw the little bit of light, it was a little bit of reflection. It can't all, when it hits an opaque object, it can't all bend and change its direction. We'll notice when we look at mirrors, we'll explain something called refraction and reflection and all of that, which will show how light can act if it hits an object. Okay, and station D was the line of sight where you had the 3 cards with the holes in them and you had to shine light through. So what's happening? Here is my light source, and we're going to make it the easiest. I'm going to use the easiest straight line. Light, when you shone it through and they lined up, the light went straight through and ended up hitting the black paper on the side, and you ended up with a light source, or light hitting the block, and it lit it up, right? So some of that light obviously hit, and it didn't go through the holes. So when you notice, whoops, even that light going through, it didn't go through the hole completely. So at the end, what you noticed is you had a light that wasn't as bright. At the end because some of it was being filtered through, or stopped by the papers. But light's traveling in a straight line because what happens is you shone it through the hole and it kept on moving right on through. In the second time that you did it, you had to move one of those holes and block the light. So this one, so say the hole is up here. These two, they were lined up. So in this second time, what happened when you shone the light through? The light came through, went through that first hole, and it ended up just hitting this second paper, and you saw the light there. You didn't see anything at the end on the paper, and that shows that light travels in straight lines. If it didn't travel in straight lines, this is what it may have been able to do. So it would still go through that hole, and it would find the next hole by curving, find the next hole, and then it could come down here. Or you would simply see, okay, it went right around and it shone back there. So that doesn't make sense. Well, it can go under it, but this one is super crazy, so it can go under. If light doesn't travel in straight lines, the way that we see things and the way that light can light up sources would be way off. Alright, the last station you had was the soccer ball station at the computer, and I'm not going to explain that one because it was explained with the shadow puppets station, so station A. So station A and station E showed the same thing. Again, when we have the shadow, we have a really dark part, and that's called the umbra, and that's caused by no light getting through. And then we have the penumbra, which is some light getting through. So those would be the little bit of light that's able to pass over, not completely blocked. The rays aren't completely blocked over top of the object. So again, how this explains or proves or provides evidence that light travels in straight lines, you can go back to station E or station A and see that explanation.